Hello T-Set viewers. Today we'll start correlation. Till now what we discussed is all about a single random variable x. Now in this we'll discuss about the two random variables x and y. This random variable will take the values x1, x2, so on xn, and this y random variable will take the values y1, y2, so on up to yn. Now see here. When the x value, when the x value is changing from random variables x1, x2, so on up to xn, now we'll see whether that is affecting the random variable y. If the change of the random variable x is affecting the random variable y, then we say that they both are correlated. Now, this is a random variable x and the random variable y. Random variable x is changing, and if there is any change in the random variable y, there is a correlation. We call it as a simple correlation. Simple correlation. Now, a random variable x is there. Now, if it is increasing, the random variable x is increasing. Now, the random variable y also increases with respect to x. అంటే x ఇంక్రీజ్ అవుతుంది కాబట్టి y కూడా అంటే x ఇంక్రీజ్ అవుతుందంటే దట్ ఈస్ అ చేంజ్ ఇన్ ద ర్యాండమ్ వేరియబుల్ x ఈస్ ఇన్ ఇంక్రీజింగ్ ఆర్డర్. ఇన్ ద ర్యాండమ్ వేరియబుల్ yలో కూడా సేమ్ అదే ఆర్డర్ ఇంక్రీజింగ్ ఆర్డర్ ఫాలో అవుతుంది అనుకోండి, దెన్ వీ సే దట్ దే ఆర్ పాజిటివ్లీ కోరిలేటెడ్. Now if random variable x is increasing and the random variable y is decreasing, అంటే the change in random variable x is resulting in decreasing the value of the random variable y, then we say that they are negatively correlated. Now the same way, if x is decreasing and the y is increasing, then also we can say that they are negatively correlated. Let us consider the random variable x and y. Now if the change in the random variable x will results to the proportionate change in the random variable y, that is, let us consider the random variable is taking the values 4, 8, 12 and 16. The random variables y is taking the values 5, 10, 15 and 20. So when you find the proportion between x and y, 4 by 5 and it is also 4 by 5, it is also 4 by 5 and it is also 4 by 5. The proportion is same here. So like this kind of increasing, okay, like this kind of relation is there between x and y, then we say that x and y are linearly correlated. Linearly correlated. Now without this constant proportion, if the x and y are both are increasing, then we can say that they are non-linearly correlated. Multiple correlation. Now we have seen only two random variables x and y. Now there is one more variable z has came into the picture. Now this all variables x, y and z are related in somehow or other way. That is, x and y is related in some or other way, y and z in the same way x and z are related in some or other way. Now the combined effect of y and z on x, y and z on x, we call that as multiple correlation. That is the combined effect of y and z, three random variables x, y and z, and we are saying that each and every random variable is related somehow or other way. Now the effect of y on x with eliminating the effect of z on x is nothing but partial correlation. అంటే ఇక్కడ ఏం జరుగుతుంది, x, y, z are somehow or other related. ఇప్పుడు మనం ఏం చేస్తున్నామంటే z ఎఫెక్ట్ని టోటల్గా రిమూవ్ చేసి ఓన్లీ y ఎఫెక్ట్ ఆన్ x ఫైండ్ అవుట్ చేస్తున్నాము, దెన్ దట్ ఈస్ కాల్డ్ ద పార్షియల్ కోరిలేషన్. Now how to find these correlations and x and y correlate అని చెప్తున్నాం, ఎలా ఫైండ్ అవుట్ చేయొచ్చు వాటిని. ఫస్ట్ విల్ సీ వాట్ ఈస్ స్కాటర్ డయాగ్రామ్. స్కాటర్ డయాగ్రామ్ or scatter plot we can call it as. This is a variable x and y. It is taking x1, x2, so on up to xn, y1, y2, so on up to yn. I'll take the ordered pairs x1, y1, x2, y2, so on up to xn, yn. I'll take the ordered pairs like this. Now I will plot all these ordered pairs in the graph like this. Now this is nothing but scatter plot or scattered diagram. This is nothing but the scattered plot or scatter diagram. Now when you check out the diagram, if the points in the scattered plot are close, that is the density is more, then we can say that they are closely related. Now if the points in the scatter diagram are spread very widely, అంటే ఇక్కడ కొన్ని ఇట్లా వైడ్గా స్ప్రెడ్ అయి ఉంటే డయాగ్రామ్లో, దెన్ వీ కెన్ సే దట్ దెర్ ఈజ్ నాన్ గుడ్ కోరిలేటెడ్, అంటే అంత మంచిగా కోరిలేటెడ్ అయి ఉండవు రెండు వేరియబుల్స్. వెన్ దే ఆర్ వైడ్లీ స్ప్రెడ్ వీ కెన్ సే దట్ దే ఆర్ నాట్ క్లోజ్లీ కోరిలేటెడ్. సో మనకి డెన్సిటీ ఎక్కువ ఉండి దగ్గరగా ఉండే పాయింట్స్ వీ కెన్ సే దట్ దే ఆర్ క్లోజ్లీ కోరిలేటెడ్. ఇట్లా వైడ్గా స్ప్రెడ్ అయి ఉండి ఎక్కడెక్కడ పాయింట్స్ అనేవి వైడ్గా స్ప్రెడ్ అయి ఉంటే దెన్ వీ కెన్ సే దట్ ఈస్ నాట్ క్లోజ్లీ రిలేటెడ్. సో మన స్కాటర్డ్ ప్లాట్ నుంచి ఓన్లీ దిస్ కైండ్ ఆఫ్ ఇన్ఫరెన్స్ వీ కెన్ డ్రా వెదర్ దే ఆర్ క్లోజ్ రిలేటెడ్ ఆర్ నాట్ క్లోజ్ రిలేటెడ్. వీ కెనాట్ మెజర్ హౌ దే ఆర్ కోరిలేటెడ్. Now, for measuring how they are correlated and what is the coefficient of correlation, the Carl Pearson is given the formula. Now, we'll see. The two random variables x and y are there. We have to find the coefficient of correlation, that is how much they are correlated to each other. And it is given, and it is denoted by R, and it is given by R is equal to covariance of x comma y divided by sigma x into sigma y. And we know what is covariance of x comma y. Covariance of x comma y is given by 1 by n into summation xi minus x bar into yi minus y bar. And we know what is sigma x, that is 1 by n into summation xi minus x bar whole square under the root. Sigma y is equal to 1 by n into summation yi minus y bar whole square under the root. Now this is the formula in terms of x and y's. Now we will see the same formula in terms of expectations. Covariance of x comma y is given by expectation of x minus expectation of x into y minus expectation of y. Sigma x square is given by expectation of x minus expectation of x whole square. Now sigma y square is given by expectation of y minus expectation of y whole square. So this is in terms of expectation values, and this is in terms of the pure values x and y. The formula is R is equal to covariance of x comma y by sigma x into sigma y. Now we will see the properties of this R value. Now this R will take the values from -1 to 1 which are included. R will take values from -1 to 1 which are both included. Now we'll see. Now when R is equal to -1, it will take the values from -1 to +1. The both are included. When R is equal to -1, we can say that the random variables x and y are perfectly negatively correlated. When it is +1, we can say that is they are perfectly positively correlated. When R is equal to 0, then we say that the both random variables x and y are independent. X and y are independent. -1 అయితే perfectly negatively correlated, +1 అయితే perfectly positively correlated, and equal to 0 అయితే x and y are independent variables. Now, you can calculate R for only linearly correlated variables, not for non-linearly correlated variables. We have already seen what is linearly correlation and non-linear correlation. Now, R is independent of change of scale and origin. అంటే మన స్కేల్ కానీ ఆరిజిన్ కానీ చేంజ్ చేసినప్పుడు గ్రాఫ్లో R will not change. It will be remain same. Now, let us consider the R value. Let us consider the R x comma y is equal to L. That is the correlation coefficient between x and y, which is equal to L. Now, R of ax plus b, cx plus d. Now, what will be the value of this? I have transformed my random variables x and y. That is a into x plus b and c into, sorry, here y. C into y plus d. Now, the value for this newly the value for this new random variables will be equal to a into c by mod ac into r of x comma y. That is a into c by mod ac into l. I repeat. So r is independent of change of scale and origin. Now r of x comma y, that is the correlation coefficient between x and y. Now if I transform my random variables x and y to ax plus b comma cy plus d. Now what will be the correlation coefficient for this new random variables? It will be equal to a into c by mod a into c into r of x comma y. Now if a and b are of same sign, that is a comma c is greater than 0, then it will be same r of x comma y. Now a and c has opposite sign, that is a comma c is less than 0, then it will be minus of r of x comma y. AC by mod AC into r of x comma y. Now if a and c has the same sign, that is a is equal to a, the product of AC will be greater than or equal to 0, then it will be having the same sign as the original. Now if a and c are opposite signs, a into c will be less than 0, then it will be having the negative sign of the original correlation coefficient. Now we are saying that if r is equal to 0, then x and y are independent. X and y are independent, but it is not true, but the vice versa is not true. That means, so when you are saying that r is equal to 0, x and y are independent, but when x and y are independent, we cannot say that r is equal to 0, we cannot conclude that. So although when r is equal to 0, x and y are independent, we can conclude that, but when x and y are independent, we cannot conclude that r is equal to 0. Standard error of correlation coefficient r is given by 1 minus r square by root n. The formula is important, just remember the formula. And the probable error of r is given by 0.6745 into the standard error of r, which will be equal to 0.6745 into 1 minus r square by root n, which is very important. The both formulas you have to remember. Now this probable error is used to find the relatability, and the probable error of r used to find the reliability of correlation coefficients. So apart from the standard error and the probable error, we have to see, apart from the standard error and probable error, we have to see the coefficient of alliation, which is given by under root 1 minus r square. The coefficient of alliation which is given by under root 1 minus r square, and also, so apart from this standard error and probable error, we have to see the correlation of alienation which is given by under root 1 minus r square, and also coefficient of determination which is given by small r square. So these four formulas are which are very important in this. You have to remember the values. So you have to remember the formulas. Till now we have seen the random variables x and y, which are taking some values x1, x2, so on up to xn. Y is taking values y1, y2, and so on up to yn. Now consider the cases when you are dealing with the marks of the candidate in a test 1 and test 2, or intelligence when you are converted into numerical values, intelligence of person 1 and person 2. So when you are dealing this kind of data, we have to transform the data in terms of ranks. Random variables x and y is there, x1, x2, x3, so on up to xn, and the random variable y is there. It is taking y1, y2, so on up to yn. Now I will find the ranks of x, that is whichever has the if you consider in terms of marks, whichever has the highest value, we rank that as 1, and the next highest will rank it as 2, next highest will rank it 3, like that we will get n number of ranks. In the same way, we'll rank y also. We'll rank y also, like 3, 2, 1, so on up to n ranks we will rank according to the magnitude of the value. Now, we'll find the correlation of the ranks of x and ranks of y. Then we call it as the rank correlation, and it is denoted by rho, and it is given by 1 minus 6 into summation di square by n into n square minus 1, where this di square is nothing but the deviation of ranks of xi comma yi. Deviation of ranks, that is here 3 into 3 అంటే 0, example 1 into 2 అంటే 1, 2 into 1 అంటే 1, అట్లా deviations తీసుకొని we have to add square the we have to add all the deviations. So ఇట్లా deviations తీసుకొని we have to square the deviations and we have to add. To square the deviations and we have to add, where n is nothing but the total number of observations, we know that. Now, this is the formula for rank correlation coefficient. Now, this rank correlation coefficient will take the values from -1 to +1, the same limits as the normal correlation coefficient. It will take the limits -1 to +1. The standard error of the rank correlation coefficient, which is given by under root 2 by n into 1 minus rho square, which is, remember the formula, standard error of correlation coefficient is given by under root 2 by n into 1 minus rho square. So when you are ranking the variables x and y, when you are ranking the variables x and y, let us assume there are two variables which has the values 90 and 90. That is, the magnitude is equal. Now what will you do when the magnitude is equal? We cannot just assign that rank 1 and rank 1 for both the variables. What you have to do? You have to just take the average of the values. You have to take the average of the ranks, not the values. Average of the ranks enta 1 plus 1 by 2, that is 2 by 2. Here it is 1 comma 1, we can assign. But in case, let us say that 8 is repeating 3 times and the rank is 3. So when you take the ranks of x and you take the ranks of y, let us consider a few data sets here: 20, 40, 60, 80, 80 and 90. So these are the values. Y లో కూడా మనకి 15, 25, 40, 50, 50 and 50. Rank the values. So highest value is 90, we will rank 1. Let us consider these are the marks. Marks let us consider these are the marks. So marks ante ranking ఎలా ఉండాలి? Highest mark will get the first rank. Like that we will rank. Now 80 ఇక్కడ మనకి రెండు 80s ఉన్నాయి. So we have to assign the 2 and 3 ranks to both the values. కానీ ఒకరికి సెకండ్ ర్యాంక్ ఒకరికి థర్డ్ ర్యాంక్ ఇవ్వలేము. సో అప్పుడు ఏం చేస్తాం మనం? 3 plus 2 divided by 2, that is 2.5. We'll assign 2.5 rank to both the values. Then 2, 3 అయిపోయింది. Next it is 4, 5 and 6. Take the second random variable y. 50, 50, 50, it is repeating 3 times. 1, 2 and 3. సో 50 వాళ్ళకి 1 to 3 ర్యాంక్స్ అట్లా ఇవ్వలేము. సో మనం ఏం చేస్తాం? 1 plus 2 plus 3 divided by 3 అంటే ఏమవుతుంది ఇక్కడ? 6 by 3, that is 2. So we'll assign rank 2 for all the candidates who got 50 marks. Then already n ranks అయిపోయి 3 అయిపోయాయి. Now I'll continue with 4, 5 and 6. Like that we will rank the variables. Now in general, if there are no ties, we have seen the row value is 1 minus summation di square by n into n square minus 1. But in case of ties, we cannot use this formula. So there is small correction in the formula. See here, rho is equal to 1 minus summation di square plus 1 by 12 into m into m square minus 1 plus 1 by 12 into m into m square minus 1, so on, divided by n into n square minus 1. Now what is this 1 by 12 into m into m square minus 1, so on? See, this m is nothing but the number of times a rank is repeating. Number of times a rank is repeating. So ఇక్కడ m value ఎంత? 2 అవుతుంది. So the new formula will become 1 minus summation di square small, as usual. We have to find the deviations, square it and we have to add. That is normal. plus 1 by 12 into ఇక్కడ m ఏంటి ఇక్కడ how many times the rank is repeating. We don't bother about whatever the rank it is. We don't bother about whatever the rank it is. We just bother about how many times it is repeating. So it is repeating 2 times. 2 into 2 square minus 1 plus 1 by 12 into ఇక్కడ డేటా వాల్యూ ఇక వైలో ఎన్నిసార్లు రిపీట్ అవుతుంది ర్యాంక్ 3 టైమ్స్ రిపీట్ అవుతుంది. అది ఏ ర్యాంక్ అయినా అవ్వనివ్వండి, ఇట్ ఈస్ రిపీటింగ్ 3 టైమ్స్. 3 ఇంటూ 3 స్క్వేర్ మైనస్ 1 ఇట్లా ఎన్నిసార్లు రిపీట్ అవుతుందో డేటా వాల్యూస్ అన్నిట్లో చూసుకొని అన్ని వాల్యూస్ ఇక్కడ ఇట్లా రాసుకోవాలి. And the numerator is same. Like this, we'll calculate the rank correlation coefficient when there are incidents, when we have the repeated ranks. Now, let us consider the 3 random variables x, y and z. As we already discussed what is multiple and partial correlations, the combined effect of y and z on x, we call it as multiple correlation. And when you have 3 variables x, y and z, so all these variables are somehow other they are related. So when you totally eliminate the value of z and find only the effect of y on x, then we say that they are partial correlations. So you directly see the formulas for it. R 1, 2, 3. Let us number it as 1, 2, 3, 1, 2, 3. Just for our reference purpose, I am numbering it 1, 2, 3. Are 1.23. That implies the combined effect of 2, 3 variables on 1. R 1, 2, 3, it is square. R 1, 2, 3 square, this represents the combined effect of 2 and 3 on the first variable. And it is given by R 1, 2 square plus R 1, 3 square minus 2 into R 1, 2, R 2, 3, R 3, 1 divided by 1 minus R 2, 3 whole square divided by 1 minus R 2, 3 square. The same way R 2, 1, 3 square, that represents the combined effect of 1 and 3 variables on the second variable, and it is given by R 2, 1 square plus R 2, 3 square minus 2 into R 1, 2, R 2, 3, R 3, 1 divided by 1 minus R 1, 3 square. So remember that R 1, 2 will be is equal to R 2, 1. So how the variable x is correlated to y, the same way y is also correlated to x. So that is one important property we have missed in the properties of R. R 3, 1, 2 square, which is equal to, is also same, the combined effect of 2 and 3 on 1, which is equal to R 1, 3 square plus R 3, 2 square minus 2 into R 1, 2, R 2, 3, R 3, 1 divided by 1 minus R 1, 2 square. So these are the formulas for multiple correlation coefficients, and this R square will be always greater than or equal to 0. It will take only the positive values, unless R small r ఏంటి -1 to +1 తీసుకుంటుంది, కానీ ఇక్కడ capital R, that is multiple correlation, will take only the positive values. We'll see the partial correlation coefficients. X, y and z, we have to eliminate the effect of y, and we have to find only how y is related to x. We will represent that with R 1, 2, 3. That is, we are eliminating the third effect and we are finding only the relation between 1 and 2 variables. And it is given by R 1, 2 minus R 1, 3 into R 2, 3 divided by under root 1 minus R 1, 3 square into 1 minus R 2, 3 square. The same way R 23.1, that is, we are eliminating the effect of x on y and z variables, and we are finding only correlation between y and z, eliminating the effect of x. It will be equal to R 2, 3 minus R 1, 2 into 3, 1 divided by under root 1 minus r 1 2 square into 1 minus r 3 1 square. The same way r 3 1.2, that is we are eliminating the effect of y and you are finding only correlation between x and z. It is given by r 3 1 minus r 3 2 into r 1 2 divided by under root over 1 minus r 3 2 square into 1 minus r 1 2 square. So these are the formulas for partial correlation coefficients. We will see a few example questions on this correlation topic. First question, C of x comma y is denoted by. So the C of x comma y is also denoted by mu 1 1, which is also known as expectation of x minus expectation of x into y minus expectation of y, which we can also write it as 1 by n into summation 1 by n into summation x minus x bar into y minus y bar, that is nothing but mu 1 1. Now what is used to measure the reliability of the observation correlation coefficient? So the probable error. So we have already discussed probable error is used to measure the reliability of the observed correlation coefficients. Now check the third one. If the correlation coefficient between the two variables is minus 0.6, the coefficient of alliation is. So we know what is coefficient of alliation, which is equal to 1 minus r square 1 minus 0.36, which will be 0.64 under root, which will be equal to 0.8. Check the fourth question. If the correlation coefficient between the two variables is minus 0.9, the coefficient of determination is. Coefficient of determination is nothing but r squared, simple, 0.9 square 0.81. So these are the simple questions which he can ask in the examination. In the next class we will discuss about regression unit. Thank you.